If you want to use AI systems to create business value, you need to understand a little bit about how AI systems are built. Because without that knowledge, you're going to be essentially flying blind when your team members or AI vendors start making very expensive decisions on your behalf. So, in this video, I'll show you a simple architecture behind many LLM based AI systems. This architecture serves as sort of a foundation for things all the way from chatbots to large enterprise AI systems. Once you understand this architecture, AI systems are going to make a lot more sense. And you'll be able to make far better decisions about how to buy or build AI systems in your own business. So let's just start with the core idea here. If you're building an AI system inside of your business, it's not just going to be a large language model. It's going to be a lot more than that. You're going to need other components to make sure that the system works well, that it's including relevant information from your business, that it's mitigating risk properly, and so on. What that means is you're going to need an AI architecture to make sure that your AI system works reliably while generating ROI and mitigating risk. Having said that, let's take a really quick look and then we'll break it down piece by piece. This is the base architecture for many types of AI systems, things from chatbots all the way up to much larger AI systems. Even AI agents are going to be sort of based on something like this. So you see that we have a user who's generating a query, then applying guardrails. You have context construction, which is essentially getting information from resources like databases and document stores, gathering relevant information from those data stores and enriching the user query with that information, then generating an output, then applying an additional guardrail, an output guardrail, to make sure that information isn't being generated that's inappropriate. So, this is the overall structure. And as I said, a variety of different types of systems are going to use this. So let's kind of dive into this piece by piece. First, very briefly, we have the user who's going to be generating a input query. So in many cases, if you go to a system like Claude or ChatGPT and you're typing in a prompt into the prompt window, that user is you. You're the person who's generating the query. Now, that's the simplest case. There actually might be some instances where the user is another system or even maybe a different AI agent. We don't need to talk about that right now. Just understand that there's a part of this architecture where an input is passed into it for further processing. The next part of the architecture is input guardrails. Effectively, in this step, we have a sort of cleaning process where it's trying to clean up the input a little bit. Typically, it's trying to remove either sensitive personal information, things that shouldn't be in the query. These input guardrails are also trying to block maybe malicious inputs that might be trying to break or otherwise hack the system. The principle here is essentially cleaning up the inputs so that the system is more risk tolerant and generates better outputs. Next, we have context construction. Now, the purpose of this is to enrich or enhance the initial query. For better or worse, many input queries that come from users, they're not always perfect. They sometimes are poorly phrased. They aren't asking or framing the question in the right way. They might be leaving out important context that might be in other sources. So, this context enrichment layer helps gather additional context to enrich the original query, which then helps the AI system generate better answers. So, this step can include things like retrieval augmented generation, otherwise known as RAG. In RAG, a system will retrieve documents from a document store or a vector database, retrieve relevant information, not everything, but it has a sort of way of searching for relevant documents and relevant information. It retrieves relevant information and then augments the query with that information. That's why we call it retrieval augmented generation. It's augmenting the input query and then using that for generation. You can also get information from things like traditional databases. And furthermore, in this step, sometimes there is a sort of query transformation or query enhancement where a system will sometimes take an input query and rewrite it in some ways. So it might rephrase the query or expand on the query a little bit to help generate a better answer. In this context step, you can also have sometimes some very light logic that can help improve processing. Now, importantly, at this step, these are typically read only actions, meaning they're just gathering information and reading that information from document stores and vector databases and traditional databases. Typically, in this step, we're not performing any write actions to those databases and vector stores. Ultimately, the goal of this step is to gather more information and context so the AI system can reason and respond more accurately. Next, we have output generation and scoring. This is kind of the step that you might be thinking about when you're thinking about a large language model based system. This is the part where the output actually gets generated. So here it will take whatever input finally gets passed into this step after it's been enhanced with additional context and the input guardrails have been applied. And the large language model will process that to create an output, but it's often a little bit more complicated than that. In an AI system where we've done some serious engineering, we're often going to have a couple of intermediate steps in this part of the system where outputs are evaluated. You might have an AI judge that is actually evaluating the output of the system. So one part of the system is actually generating, but you might have a secondary AI system that is just trying to evaluate the outputs. In many cases, this will involve scoring the output in some way, and in others, the system might actually generate multiple different versions, score all of those, rank them, and choose the best one, or have some sort of system for choosing the best output to deliver to the user. So, the important thing to remember here is even though this step is where the output actually gets generated, it's a little more complicated than just a simple LLM call. The process of generating an output in a well engineered AI system might have multiple steps, including scoring and ranking, and it also depends on all of the other parts of the architecture that we previously discussed. Next, and finally, at least for this somewhat simple architecture, is a set of output guardrails. Typically, in this step, we're doing one final pass over the output to make sure that it conforms to expectations, conforms to the right output structure, and doesn't have any bad information or toxicity in the output. So here, these output guardrails are going to be checking for things like factual consistency and something that we can call schema enforcement. Essentially, if the output is supposed to be in a specific structure, like a JSON file or a CSV format or just plain text, this output guardrail is going to make sure that the output conforms to those requirements. It's also going to try and filter out any sort of output that might be considered toxic. Now, that's maybe an entirely separate conversation about what toxicity is and how we detect it, but we're trying to remove things that are going to be kind of harmful or otherwise a bad experience for the user. Things that might be mean or harsh, things like that. In this step, we're also going to be trying to remove things that are privacy restricted. So, any sort of information that shouldn't be sent to a particular user, personal information from a database, private information, things like that are going to be typically filtered out in this step. You might have seen if you go to ChatGPT and ask it personal details about a private person, a person who's not famous, it's very often going to deny those requests, saying, I can't give you information about individual people. Those output restrictions are often applied in this output guardrail component. Effectively, this layer gives one last pass to make sure that it's excluding information that shouldn't be sent to the user and making sure that the results are clean and appropriate. So, this architecture might seem simple, but it's important to remember that it is the foundation for many other types of AI systems. For example, AI agents. And if you'd like to learn more about agents, including what agents are, how they're structured, and the sorts of use cases that we can use AI agents for, you'll probably want to check out this video up here, AI Agents for Business.